Hey everyone, today we'll be doing the USACO 2022 US Open Contest Bronze Level problem number 2, Counting Liars. So essentially the problem just states that Bessie the cow is hiding somewhere in a number line, and each of Farmer John's n cows, which is between 1 and 1,000, have a piece of information to share, which says that Bessie's hiding at some location less than or equal to P, or she's hiding at some location greater than or equal to P. However, some of the cows are lying, which means that the hiding location isn't consistent with the answers of all of the cows, so we're supposed to figure out the minimum number of cows that must be lying. So the first line would contain n, followed by the next n lines containing a character and then a number, with the character being either G or L, which G meaning that the ith cow that Bessie says the ith cow says that Bessie's hiding location is greater than or equal to the index, while the L means that the ith cow says that Bessie's hiding location is less than or equal to the index. We need to find the minimum number of cows that must be lying. So before we get started into the actual problem, let's just look at the cases and see how they work. So in this case, we have two cows that are in the herd, and we have G3 and then L5, which basically says that the first cow is saying that Bessie must be at a spot that is greater than 3, while the second cow that says that Bessie must be at a spot that's less than 5. So as a result, the only spot that works such that both of these conditions are true is 4. And as a result, it's possible that none of these cows are lying. In this case, we have one of the cows says that Bessie is greater than a 3, and the other cow says that Bessie is less than 2. And in this case, you can see that there's no possible spot that Bessie can be such that both of the cows are lying, but both of the cows are true, so that means that at least one of the cows is lying. So let's look at this in a bigger example. So over here, I have a set of numbers on a number line. Obviously, they're all sorted. So the way that we can solve this problem is by going through each of these indexes over here and then seeing, well, if Bessie was at that specific index, how many other cows would agree with that, and how many cows would be lying? So if we start over here at L is equal to 2, at 2, and index is equal to 2, this says that the rest of the cows say that Bessie must be greater than 3, Bessie must be greater than 7, and that Bessie must be less than 8, and then Bessie must be greater than 9. So assuming that she is at 2, then in that case, we see that these 3 cows over here, the ones who would all say greater, are lying. In this case over here, where the cow says that Bessie must be greater than 3, but Bessie must be at 3, we can see that the first cow would be lying because Bessie's not less than 2. In this case, the cow at index 7 would be lying, and the cow at index 9 would be lying because none of those conditions hold true, assuming that Bessie is at this spot over here. However, this condition where Bessie is less than 8 holds true, so that means 3 of the cows are lying. Over here, we have that Bessie is exactly at 7, so we're going to assume that she is exactly at 7, and as a result, we see over here that this cow over here is lying because Bessie cannot be less than 2 because she's at 7. This cow over here is saying the truth, and then this cow over here is saying the truth as well, and the last cow is lying because Bessie cannot be greater than 8 because she's at 7. So we see here that 2 cows are lying. And if we repeat a similar process for the rest of the things, we see that there's 3 cows lying for the first 2 ones, and there's 2 cows lying for the second 2 ones. So how can we code this? Well, let's actually do the code now. So we're gonna obviously import all the libraries. So include bits standard C++, which includes all the libraries. And we use namespace standard. Oh, oops, wrong markets. And then what we do after that is we input n. And then after we input n, what we want to do is basically create a vector, create like an array of the different locations as well as what each of the cows is saying. So if each of the cows is saying either greater or less, we want to create a way to track that. So what we're going to do is create a vector which contains a pair of integer and character. I'm going to call it locations, or LOC. And then for each of these, we're going to actually input all the things that the cows say, like all the locations. So for int I is equal to 0, I is less than n, I plus plus. So when we input that, what we want to do is we want to initialize a character variable and a number variable such that we can input it. So we can do that by doing int p, which is the index, and then char c, which is the character that either of L or G. And what we want to do is input first. We want to input the character, and then the number. So we can do input c, then p. And as a result of that, what we can do after that is we can just put that into the vector over here. So loc.pushback. And we can make a pair out of these and pair it as p, c. And the reason why we're putting the integer first before the character is because when we sort it, we wanted to sort it based on the integer integer index rather than whether it's an L or a G. So now what we're gonna do is sort the input just to make sure that just to make sure our algorithm works. So that we can just to make sure our algorithm works. So print sort. We want to sort it based on the beginning of the location all the way to the end of the location. And then what we're gonna do is we're gonna run a for loop describing the process similar to before, where we're gonna start at each specific index and then check check all of the rest of the indexes to make sure that to count the number of cows that are lying. So what I'm gonna do is first I'm gonna create a variable called min liars, and I'm gonna set it equal to n. And as we iterate through and check all the different possibilities, our min liars will keep going down based on the minimum of the values of liars. So for int I is equal to 0, I is less than n, I plus plus. So we're going to iterate through the starting location of Bessie if possible. And then what we're going to check next is first we're going to create a variable called num liars is equal to 0, and that's basically just going to count the number of liars in that specific iteration. So for example, over here we have 2. If we start at 2, we would have num liars of 3 at the end, and so on. And then what we're going to do after that is we're going to run a for loop. So for int I is equal to 0, j is equal to 0, j is less than I, and j plus plus. And the reason why we have this is what we're gonna do now is if we're gonna check that if the location at j, right, the location at j dot second is equal to L, which means that if the index of that specific location has an L over here, that must mean that if I is after that, that must mean that it's lying. So for example, let's say we're over here, right? This is where our I is, and our j is over here, and it sees, okay, well if the index specifically says it's a location of L, that means it's lying, because there's no way that the cow which is at I over here is all the way behind L over here. So that means that this cow is lying. So we can increment the number of cows, number of liars. And then we're going to repeat the same process for if it's g. So for int j is equal to I plus 1, j is less than n, j plus plus. If location at j dot second is equal to g num liars plus plus. So we can imagine this in a similar scenario over here. So let's say that instead our I is over here. So let's say our j is over here. Well, we know that this cow would be lying over here because of the fact that there's no way that I can be greater than here, because I is already before here. And the same thing applies for here. If j is over here, our location at Bessie cannot be greater than 9 because our Bessie's location is 3. So as a result, that's what this loop does. And then at the end of that loop, what we're going to do is we're just going to make sure that we find the minimum of number liars and minimum liars to basically decrement the count of minimum liars after each iteration. Liars, and then we're going to print it out at the end. And then that should be good. So let's submit this and see what happens. So here I'm about to submit the file. And it looks like it works.